right. So again, just kind of going back through, reiterating, hitting up more exponential growth and decay. I just want to do a couple more of each related rate and growth and decay problems with you today, and then we'll continue reviewing. So in number 1, it says dy dx equals e to the x over y squared. So once again, you want to get y's with y's, x's with x's. So we're going to rewrite this as y squared dy equals e to the x dx. And then we are going to integrate both sides. So we get 1/3 y cubed equals e to the x plus c. We're given that when x is 0, y is 1. So we're going to plug in 1 and 0 here. Anything to the 0 power is 1. So we end up with 1/3 plus 1/3 equals 1 plus c. So I get that c is equal to negative 2/3. So then solving so that this is in terms of y, I have 1/3 y cubed equals e to the x minus 2/3. So we're going to multiply everything by 3. So I get y cubed equals 3e to the x minus 2. And then we're going to take the cube root of both sides. And number 2, we bring back trig. So once again, we're going to cross multiply to get cosine y dy equals sine x dx. I'm going to integrate both sides. Antiderivative of cosine is sine. Antiderivative of sine is negative cosine plus c. Plugging in 0 for x's and 3/2 for y. 3/2 pi, sorry, for y. I get the sine of 3 pi/2 equals negative cosine of 0 plus c. Cosine of 0 is 1, so you have negative 1. Sine of 3 pi/2 is also negative 1. So c becomes 0. So then you have sine y equals negative cosine x. To get rid of sine, you take sine inverse. So we get y equals the inverse sine of negative cosine x. A radioactive element decays exponentially proportionally to the mass. 1/2 of its original amount remains 5,750 years later if 10,000 grams of the element are present initially. So that's again like 0, 10,000. Its half-life is 5,750. So that means at 5,750, there is 5,000 left because that's half of the initial and the amount of time. How much will be left after 1,000 years? So we want to know 1,000, comma, question mark. So again, it's y equals y naught e to the kt. So my y naught is 10,000. I can find k by using the half-life idea. So I have 1/2 equals e to the 5750k, taking the ln of both sides. K equals negative natural log of 2 over 5750. So going back to that original idea, y equals 10,000 e. Now I know negative ln 2 over 5750 t. And then I want to know y when t is 1,000. So at this point, it's just a calculator question. So you go to your calculator, type in 10,000 e. I like to put everything in parentheses. And I get that there is 8,864.3512 grams after 1,000 years. It says, write the differential equation that models the following statement. The rate of change of Q. So when you see rate of change, you think derivative. So it's going to be derivative of Q with respect to T. So that means dt. Means equals. If you see proportional, you know you need K. It says inversely square of T, so it's K over T squared. And again, anytime you see inversely proportional, think division. So this is the differential equation. And then if you were writing the equation for Q, it would be dq equals K over T squared dt. You would integrate both sides, and you'd have Q of T equals negative K over T plus C. The rate of change of V, so dV dt, is equals proportional to V, so not inversely, therefore no division, just kV. When t is 0, V is 20,000. When t is 4, V is 12,500. What is the value of V when t is 6? So we need to integrate and get our equation. So you get 1 over V dV equals K dt. Giving ln V equals KT plus C. Giving capital V equals CE to the KT. Because again, anytime you E both sides, that plus C can come down as the constant. Now, you have two choices with our V naught and our 20,000. You could have plugged that in here or in here. So you see C is equal to that natural log of 20,000. And again, if you had done it at this step, then when you E both sides, that ln of 20,000 comes down just as the 20,000. If you plugged it in here, it's 20,000 equals C E K 0, which made that 1, which makes finding the C a little bit easier. So we have V equals 20,000 E to the KT. Now we're going to go about finding K using the 4 and the 12,500. So we get K equals the natural log of 5/8 all over 4. And then we have, what is the value of V when t is 6? So we get V equals 20,000 E to the ln 5/8 divided by 4 times 6. So you get 9,882.1176. And again, that represents like whatever the units of V is.